Hello students, how are you? So in this lecture number 9, we will solve few numericals of type D. So formulas we will use based on work done in joules and power. So power equal to work done by time, therefore power equal to I square into R into T by T. Here we will cancel the time, therefore power equal to I square into R watt, power equal to V square by R watt, therefore power equal to V into I watt. Here watt is the unit for power. Now let's see the question number 1. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Now write a given values here. Heat is given H equal to 100 joule. The resistance R is 4 ohm and the time T equal to 1 second. Now we have to find out the potential difference V. The formula we will use here is heat equal to V square into T by R joule. Alright, now rearrange it. V equal to root over H into R by T. Therefore V equal to root over 100 into 4 by 1. Therefore we will get V equal to root over 400. Therefore the V is 20 volt. And your answer is the potential difference across the resistor is 20 volt. Now let's see the question number 2. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. Right here, what are the given values? The coulomb is charge is given, that is 96,000 coulomb. Time is also given in hour and the potential difference, that is 50 volt. Here we have to find out the heat generated. Okay, so write the values. Potential difference equal to 50 volt, time T equal to 1 hour. We have to convert it into seconds. And the charge is 96,000 coulomb. We have to find out the heat. So see here, heat has 3 formulas. So we will use the formula based on our given values. So here we will use the third one. Alright. So formula we'll use. First we have to find out the current also. And then the heat formula. Now let's solve it. First find out the current. Put the values. Let me do the calculation. You can also do the calculation by yourself. But still I am helping you. Therefore, we will get the current I equal to 80 by 3 ampere. Now find out the heat. Here put the values. Again after calculation, we will get heat equal to 4.8 into 10 to the power 6 joule. So the answer is heat generated is 4.8 into 10 to the power 6 joule. Alright. Question number 3. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the potential difference and heat developed in 30 seconds. So here we have to find out the potential difference and the heat also. Here the time is given and the resistance is given and also the hour current is given. Okay, so write the given values. Current equal to 5 ampere, time T equal to 30 seconds and resistance is 20 ohm. Okay, we have to find out the heat and the potential difference. We will use the formula here to find out the potential difference. V equal to IR. And for heat, tell me which formula we will be using here. See what are the given values. Based on that only we will be using. So here we will use the third formula. H equal to V into I into T joule. Okay. Now let's solve it. First find out the potential difference. Put the values. V equal to 100 volt. Okay. Now find out the heat. H equal to V into I into T. Put the values here. Do the calculation. We will get heat equal to 15,000. Therefore heat equal to 1.5 into 10 to the power 4 joule. So the answer is the amount of heat developed in the electric iron is 1.5 into 10 to the power 4 joule. Is that alright? These are all formula based questions. You can do it easily if you know the formula. Okay, now see the question number 4. An electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220 volt. So what is the current in each case? We have to find out the maximum current and the minimum current in each case. Now write the given values. Power at maximum rate P max equal to 840 watt. and power at minimum rate P minimum equal to 360 watt and the potential difference V equal to 220 volt. We have to find out the maximum current and the minimum current. So therefore we will use the formula power equal to V into I. Let's solve it now. When heating is at the maximum rate, P max equal to 840 watt and volt equal to 220 volt. Therefore P max equal to V into I max. Therefore I max equal to P max by V. Now put the values. I max equal to 840 by 220. After cancellation we will get I max equal to 3.82 ampere. Now for the second case, when heating is at the minimum rate, P minimum equal to 360 watt and V equal to 220 volt. So therefore you see here I minimum equal to 360 by 220. Now do the cancellation, we will get the I minimum equal to 1.64 ampere. So therefore the maximum current is 3.82 ampere and the minimum current is 1.64 ampere. Okay, now let's see question number 5. An electric bulb is rated 220 volt and 100 watt. What it is operated on 110 volt, the power consumed will be. Alright, so see here power 1 is given 100 watt and we have to find out the power 2. So power P1 equal to 100 watt and the potential difference V1 equal to 220 volt and potential difference V2 equal to 110 volt. So we have to find out the power P2. The formula here is P equal to V square by R. Now let's solve it. First we have to find out the P1. Okay, they are equal to V1 square by R. Now put the values. 100 equal to 220 square by R. Therefore we will get R equal to, do the calculation, we will get resistance equal to 484 ohm. Now resistance remains constant even at 110 volt. Okay, therefore power 2 equal to V2 square by R. So power 2 equal to 110 square by 484. Therefore power P2 equal to, do the calculation, then we will get the power P2 will be your 25 watt. So the answer is the power consumed at 110 volt is 25 watt. Okay, done. Alright. Question number 6 is an electric bulb is connected to a 220 volt generator. The current is 0.5 ampere. What is the power of the bulb? We have to find out the power of the bulb. Volt is potential difference is 220 volt. Current is 0.5 ampere. We have to find out the power. Now write what are the given values. Current is 0.5 ampere. The potential difference V equal to 220 volt. We have to find out the power. So power formula is V into I. Do the calculation now. P equal to 220 into 0.5. Therefore power equal to 110 watt. The answer is power of the bulb is 110 watt. Okay. This is question number 7. An electric heater of resistance 8 ohm draws 15 ampere from the service mains for 2 hours. Calculate the rate at which heat is developed in the heater. Now what are the given values? The resistance R is given, that is 8 ohm. The current I is given, that is 15 ampere. We have to find out the power. So we know that the power formula is P equal to I square into R. Now let's solve it. Put the values. P equal to 15 square into 8. We will get P equal to 1800 joule per second. So don't forget to write the unit. Therefore the answer is heat is produced by the heater at the rate of 1800 joule per second. Let's move to question number 8. Two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to electric mains supply. Now what current is drawn from the line if the supply voltage is 220 volt? We have to find out the current here. We know that P1 and P2 equal to 100 watt and 60 watt respectively, where the potential difference is 220 volt. So at the given values, power 1 equal to 100 watt and the power 2 equal to 60 watt and the potential difference V equal to 220 volt. we have to find out the current. Therefore, we will use the power formula P equal to V into I. Now, since the current drawn by the bulb of rating 100 watt is, we will mark the power and the current here is as 1. Therefore, power 1 equal to V into I1. Rearrange it. We have to find out the current I1 here. I1 equal to P1 into V. Therefore, I1 equal to 100 by 220 ampere. So, similarly, current drawn by the bulb of rating 60 watt is, here we will mark the power and the current as P2 and I2. Therefore, P2 equal to V into I2. Again, rearrange it. We will find the current 2, I2 equal to P2 by V. Therefore, I2 equal to 60 by 220 ampere. Now, current drawn from the line equal to I1 plus I2. We will add it. Therefore, after calculation, we will get the current drawn from the line equal to 0.727 ampere. Okay, so this is the answer, 0.727 ampere current drawn from the line. Now this should be the question number 9. By mistakenly it is written question number 5. Okay, see here, two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combination would be, here the 4 options are given, so among them one is your answer. Can you do it by yourself? If not, definitely I am on your back. Okay, see here, your answer is 1 is to 4. So how we got this answer, I will show you. Let us consider RS be the equivalent resistance of the wire when connected in series, and RP be the equivalent resistance when connected in parallel. Alright, so therefore RS equal to R plus R equal to twice R, and 1 by RP equal to 1 by R plus 1 by R equal to 2 by R, and 1 by RP equal to R by 2. Okay, so heat equal to V squared into T by R. Therefore, the ratio of SS plus HP here, S means in series and P means in parallel. Okay, now put the values. V square into T by RS divided by V square into T by RP. Okay, the ratio is RP by RS. Therefore, SS by HP equal to 1 by 4. Is that clear now? Okay students, this is all about today's lecture. Keep on solving more and more questions, and if you are interested to do live classes where you can clear your doubts as well, download the app Nakhyatra and the link is given below in the description box. Okay guys, thank you.